Hi, my name is Adi Stern from the Weizmann Institute of Science. Together with my friends here, we would like to tell you about Weizmann research on quantum science, about being an international student and postdoc at Weizmann. You know, we are always looking for excellent students and postdocs, and about our new baby, the soon-to-be launched online course on topological quantum matter.
Quantum research at Weizmann is based on constructive interference, the many-body interference of theoretical and experimental work, of different research groups, and of Israeli and international participants. On the quantum computation front, we make computing and memory qubits using a very diverse set of physical systems: trapped ions, nuclei of noble gases, Josephson junctions, laser arrays, and even photons confined to cavities. We study theoretical quantum cryptography and a variety of quantum sensing techniques, including envy centers in diamonds and ultra-cold atomic interferometers for developing very precise sensors and for searches of new physics.
In the Department of Condensed Matter Physics in Weizmann, we study quantum matter using a diverse set of tools. Our groups build interferometers and measure thermal transport in quantum devices to reveal exotic properties of topological quasi-particles. Our department may have the highest density of quantum scanning probes on the planet. We have unique microscopes that image local temperature, electric and magnetic fields, quantum interference, and much more, enabling us to visualize quantum matter on the nanoscale. Our theorists form detailed physical pictures of topological states of matter, correlated phases in twisted Moiré system, chiral molecules, and much, much more.
5 years ago, I joined the Weizmann Institute. Now I'm an associate professor here in the Faculty of Physics. My field is theoretical physics. It's about quantum materials. I study how electrons behave inside the material, like for today's semiconductor and a new technology. We are not too big, not too small. It's big, I have exposure to different directions. It's small, I have direct contact with the people around me from physics, chemistry, sometimes even biology.
I completed my PhD at MIT, where I studied 2D materials, specifically developing new magnetic materials down to the atomically thin limit. As a postdoctoral fellow in Professor Shachal Alani's lab, I'm helping to develop new scanning probe techniques to study 2D materials in ways unlike any other lab in the world. Weizmann provides many postdoctoral funding opportunities that both support our research and also enable us to travel to conferences like APS to present our work and stay connected with the rest of the scientific community.
I grew up in New York, did my undergraduate degree in physics at Harvard, and I'm now a PhD student here at the Weizmann Institute with Professor Roy Ozeri. Our group studies trapped ion physics. Specifically, we're working on a new trap designed for 50 ions that's going to be a 50-qubit quantum computer. One of our goals is leveraging the full connectivity of qubits in our system to implement different protocols in quantum computing. As a student here at the Weizmann Institute, you have access to leading minds in many different fields. There's also an atmosphere here of creativity and collaboration that is very conducive to doing advanced research.
I'm an assistant professor of physics at Columbia University. I met Professor Adi Stern in the summer school of physics. We had amazing science discussions and we found projects to collaborate with. That led to a high-profile paper published, and I ended up going to join him for a postdoc. I find a very nourishing environment to do science. There's a lot of collaborations within the department. It's not very hierarchical, so it's an environment where you feel like you can explore science in a very fun and across-the-board way, to talking from students, master students, PhD students, postdocs, professors.
Relying on our years of research of topological states of matter, we now embarked on a new project, an online course on the subject, titled Topological Quantum Matter. Topological states of matter are a favorite subject of research here at the Condensed Matter Physics Group of the Weizmann Institute of Science in Israel. We conduct cutting-edge research on those quantum states. We teach courses focused on those states. We develop theories. We discuss these theories. Now we gathered leading researchers of the field to provide you with a comprehensive outlook on topological states of matter. Join us for a journey aimed at forming a clear physical picture of the essence of topological states of matter.